So can I just check if we have Peter? Peter's there, and Mohamed is there. Great, great. So Peter, Mohamed, can you hear me? Peter?
Yes.
Great.
Yes.
Thank you. And Mohamed?
Yes. It's fine.
Great. Super. So good morning, everybody. So it's a real pleasure to have you here today. So so great thanks to the leadership of Ioannis Pitas. We have a fantastic AIDA Academy, the AI Doctor Academy of Europe. It's a huge undertaking, and he's done such a fantastic job. So I think we need to really thank Ioannis for this really fantastic thing. And today we're doing a couple of things. We're going to have a panel about AI education at the PhD level. We're also launching this curriculum, the AIDA curriculum, and this has a number of core subjects and a number of special topics. So we would like you to go and visit that, and you'll find it at the AIDA website, the PhD curriculum. And so it's very much modelled on the Russell and Norway curriculum, but modified based on sort of European taste in some sense. So Peter and Mohamed, who are online, have been very instrumental in this, Ioannis obviously, and many others. So we have this great curriculum, and I hope that you give us feedback on that. So in a sense, we're launching that today to you. So the 7 key or core subjects are things like foundations of AI, AI paradigms and representations, deciding and learning how to act, machine learning, vision, NLP and analysis, and ethics and governance. And then because of the networks, the 4 networks that originated the ICT 48 call, there are special topics. And of course, we need to reach out to the other, at this point, 5 networks to see if they would like to contribute something. So there's a call to action to you that if you're teaching in any of these areas, please get involved in AIDA. Ioannis will probably be asking you to do this many times today, and Mohamed also. Please teach courses, please offer courses on the AIDA curriculum and fit them in here. And of course, we're very keen to get resources from you to add to this website. So the focus today is really to talk about AI education at the PhD level, and we have a fantastic panel. We have Ioannis Pitas over here, we have Paul Lukowicz, and online we have Peter Flach, we have Mohamed Chetouani. So we'll basically ask each of them to make a contribution, and then we'll open it up to the floor. I'll ask some questions. It's very free form, it's very easy, and hopefully you'll enjoy the next hour. So Ioannis, maybe you'll talk to us first. Thank you.
Sure, thank you very much, Barry. Yeah. Can I have the my presentation, please? Okay, that one. Okay, there's a number of issues I would like to touch. First of all, there is a big question whether AI, science and engineering is a new scientific discipline. In my view, it is, because just simply the computer science, the computer engineering have expanded so much that they cannot really accommodate things anymore in the same program of study. So we need specialized programs at bachelor level and also master level, and AI could be one of them. Of course, we have in AI interdisciplinarity that is stronger than in classical computer science, and there are some issues there with respect to depth versus shallowness that we have to address. Essentially, computer science and engineering currently spawns new disciplines through specialization. We have web science, data science, AI science and engineering, and in the past we experienced the same situation at the end of the 19th century when physics spawned engineering disciplines, for example, electrical engineering and mechanical engineering. So maybe we live in revolutionary times that we see the generation of new disciplines, and of course to have a new discipline, this means that we have a new curriculum. Already Barry showed the first approach, the AIDA approach to curriculum. Of course, to support such curriculum, we need lots of mathematics, and this is a distinguishing feature between the current status and the past, because typically in computer science in particular, there were not that many mathematical courses. We need more. And also we need some input from classical studies, because there are issues related to philosophy and ethics that engineers and scientists are not really aware of. So, and then the question is, do we really prescribe universal AI scientists? And this is really doable. So these are things that have to be answered through the curriculum. In AIDA, thanks to all ICT 48 projects, we created the AI curriculum at PhD level. Now we have to bring it to bachelor and master level as well. And also in the AI for Europe project, we created an AI educational taxonomy that is compatible to the AI curriculum. So now we have AI curriculum and AI educational taxonomy that can work together and become something like the ACM curriculum on computer science. And we try to bring the entire structure in the classical, let's say, curriculum structure. So we have core courses, elective courses, prerequisites, support courses. For example, Barry already has shown you a list of AI core courses like deep learning and machine learning and so on. And then we have a number of elective courses, because this area AI science expanded so much in the past few years. So it's a long list of elective courses that students can choose from. And of course, we need lots of mathematics to support the entire structure of an AI bachelor and master program. Besides mathematics, there are things that come from, let's say, neuroscience and cognitive psychology as well, that are really important when teaching AI. And then we have a support courses that come from a classical CS curriculum. So now, here in Europe, there are, as we have already heard in the previous session, lots of efforts to upgrade the AI studies through the creation of AI departments, AI programs, and so on. My proposal is to create an international AI academy at European level. Not AIDA. AIDA is for doctoral studies. AIDA can be part of the International AI Academy. So essentially, my proposal is to create a federation of European universities on AI that has a special cutting-edge legal status, so we don't have to reinvent the wheel. If the legal status in the US is better, then we can adopt one, and we can start sharing courses, sharing educational material at the European level. And to do this, of course, we need special European Union funding, and there are similar efforts nowadays on other topics. For example, there is an initiative for European studies on renewable energy. So it's not only AI that tries to attract support from the European Union. This has already been done in other cutting-edge technologies as well. And we can have in this International AI Academy a number of departments: AI science and engineering, robotics, data science, and possibly network science, bioscience, and so on. Nowadays, as information really, now I move to a little bit different topic that's related to the structure of the university studies as related to AI. Nowadays, in the past, we had matter studies that were supported by natural sciences, and then we had the man-made environment that was supported by engineering. Now we have information that raises to the same level with matter. So my view is that we should create schools of information science and engineering where many related departments can participate. For example, the departments of computer science, mathematics, computer engineering, electrical engineering, artificial intelligence, they should be under the same umbrella so that they create a critical mass to support AI studies within the university, but also to support other sciences as well. Because one of the main issues nowadays is the mathematization of all sciences. The last bastion was languages. Now in languages, words have been transformed into vectors. This means that mathematics enter into humanities. So how can this be done? It can be done through service from a central AI school in the university, but my proposal is that at the same time we should have departments, specialized departments in each school, let's say, of arts and humanities. We can call it Department of Mind and Social Science and Engineering, that is going to try somehow to infuse this mathematization into the classical humanities studies. And because there's no other alternative. The other alternative is to have philological or linguistic engineering in an engineering school, which is something that I wouldn't really like personally. And then same thing can happen in medical science, because there are challenges there. My proposal is to create a department of bioscience and engineering, which is essentially an expansion of biomedical engineering, and it's going to infuse the mathematization into the medical studies. So all these are very challenging issues. They're not easily done. I think that I've passed my time, and we can discuss these issues later on during the discussion.
Before we have Paul, thanks, Ioannis, that was great. So before we have Paul come in, let's have someone from online. So maybe Peter Flach will go next. Peter, do you have some slides you want to present to us?
Yes, I do.
Great. So my
can you hear me?
colleague here might help with that. 1 second now. I'm going to stop sharing Ioannis' slides. Thanks, Peter.
Oh dear. Open the dreaded open system settings. Just say.
And if you want me to come back to you, maybe Mohamed would be ready. So
maybe, yeah, maybe.
Yeah. Mohamed, are you ready to go? Mohamed, are you there?
Yeah, sorry. Yes, I'm here.
No problem. Do you want to present? Have you some slides, or do you just wish to speak?
Yes, just 1 minute.
Great.
Yes, I have some slides.
Great, thank you. And so we'll go to Mohamed, then Paul, who's in the room, and then back to Peter. So, great.
Okay.
Super. Looks good?
Okay, so you are getting my slides, I think, no?
Not yet.
You see my screen?
Yes.
We see your screen.
Okay.
We see us on your screen.
That's fine now?
Not yet. We don't see your slides. We see
Okay.
you're sharing the Zoom interface. Yeah. Perfect. Thanks, Mohamed.
Okay.
Yeah. So if you put them into.
Okay, that's fine now.
Perfect. Great. Thank you. Perfect.
Okay, great, thank you. Okay, so my name is Mohamed Chetouani. I'm professor at Sorbonne University. So I'm here also for HumanE-AI Net, and Paul will say more probably after. So thanks to the organizers of this event, and thanks to Ioannis and Barry and all the colleagues that were working on the curriculum. I wanted to say a bit more about the human-centric AI part, because in the HumanE-AI Net we have been working a lot on that, and probably not going back on the topics, but trying to illustrate what we have been doing in terms of content and what you could have, and this will highlight some discussion that we could have after regarding how we can implement that. So first, something that we have been discussing a lot in HumanE-AI Net, but also I would say in the curriculum, is what means human-centered AI. It's clear that this is about having AI that is beneficial to humans and society, but the problem is or the challenge is how to translate that. As you heard before, one of the challenge of AIDA, but also the all the European project networks, and is to also train people on that. So how we can train on that, and this is based both on the research side, but we need to translate that on technology and scientific research questions. And this is what we have been facing during the project, and we are still facing that. And we try to illustrate a bit of how we do that and how it comes also to the curriculum. So first, in the curriculum, in the human, if we have a look to what we have been doing in HumanE-AI and then our contribution to the AI curriculum, the first thing is human-centered machine learning. So here it's of course building on the core AI, but I will say some specific stuff that we are doing here is that we are doing a lot of multimodal machine learning. So what does it mean for us is that most of the time we are dealing with humans. We are not trying to detect, let's say, object, and of course we could, but what we are doing is trying to see the multimodal approach, the communication, how people also behave, trying to have a short-term but also long-term interactions. So it's really specific because we need to develop these models. So of course, we build upon on using technologies on recent works on AI, core AI, but there's some specific stuff that if you want to train people on how to analyze human behaviors, you need to know, for example, what means facial expressions, what means gesture, which kind of gestures we could have. So these are examples. Then we have explainable AI, and I think others will talk about it, but also some stuff that are very relevant for us, which is interactive machine learning, which is when you have humans in the loop, how you deal with that, how you train models that are able also to be trained by humans, for example, by giving instruction, giving demonstrations, and others. We have a strong part that we are contributing in HumanE-AI, which is about human-computer interaction regarding user modeling. So how we build models of users online, but also using data-driven models. And sometimes it's also linked to what has been said by Ioannis, cognitive science, because here you need to know more about humans and how to translate that on models. There are works about collaboration, argumentation, even negotiation. These are topics that we have been developing. We have a large topic that is social AI, which is really about, I think one of the key words that we have been developing during the project is co-evolution, because now that the AI is deployed in largely at the society level, both let's say the AI models are changing, and we are aware of that, but also humans and the society is changing. So how we deal with that? So we have people in sociology using AI techniques to analyze the co-evolution, but also to see the impact of humans on the AI. There were a lot of works on like social simulation, so already at the society level, how we can put agents that do that. There is a part that we developed a lot in HumanE-AI, and this is also included in the curriculum, and I think that's a very strong and makes a very strong contribution in Europe about ethics and law and society, and we have been working a lot on that, and we have regularly let's say tutorials and that are open, and the materials about governance, AI Act, and ethics, and even some stuff on politics. So making that concrete, so we have been, for example, 2 years in 2001, we have been 21, we have been working on an advanced lecture. And this is a book that we have been, let's say, proposing. And you see, let's say, some of the chapters. We have, we found already these ideas of topics like human-centered machine learning, explainable AI, ethics. And this is based on internal workshops. So we have been, for example, developing a lot of workshops inside the HumanE-AI Net on transformers, for example. And we have several chapters and lectures on that. We have probably Paul will say more about micro projects, but we have a lot of micro projects in terms of collaborations, and some of them also are producing, let's say, lectures, educational materials that we use in the curriculum. We have also a contribution from philosophy. So some of the authors and some of the contributors are not in AI, so they are more interested in working on AI, but they are not on the core AI, and they produce, like, for example, this chapter, why and how should we explain AI from a philosophical point of view. So everything is open as most of the stuff, so maybe we'll switch that, but most of the stuff that we are proposing is not only, let's say, as I said, one of the challenges is to produce the materials, and we try to produce resources like in GitHub, notebooks and databases that we try to share through AIDA, but also through other let's say stuff that are more or less open, or you can access to them. The last thing that we are currently doing is a handbook of HumanE-AI collaboration. So it's an online book. It's a continuous publication. So each time we have a chapter or sections, we can publish them. It will be open access, and this will be, and we aim to have a reference on HumanE-AI collaboration that is not only on HumanE-AI Net. We have a lot of, and we are invited a lot of authors and contributors from other networks, or even broader than that. And we are making now a strong focus on generative AI. So just to finish and give you an overview, we found again, and the handbook is really to train also people and to be a reference. And we found again what we have been discussing in terms of contribution to the curriculum is what means human collaboration, a lot of stuff regarding multimodal machine learning using recent models, foundational models. We have been doing a lot of reasoning, learning, evaluation and experiment is part of what we are doing, and co-evolution and what we have in ethics. Okay, so that's all for my side, and thank you for your attention.
Great, thanks, Mohamed. And next we have Paul Lukowicz from HumanE-AI Net.
Thanks, Paul. So I don't have big slides. I just wanted to talk quickly about this at 3 points. So the first point is a lot of discussions we have in this forum is about how Europe needs to catch up on this or that, how we are behind. And I think one point I would like to make is that actually if you look at higher education in science and computer science, Europe is actually not behind. And one thing that you always hear people complaining about is how the US hyperscalers are actually scooping us up our best graduates and our talent, and what do you do about it? The reason they are taking those people in is, of course, because they're really well educated. And I think one of the reasons that that we have people who after university computer studies PhD are well educated is, and it sort of contradicts everything what Ioannis was saying, is I believe that in most computer science universities, the education at least starts with the basics, right? So in computer science and in Germany and other countries, you really have very solid mathematics education. You have a very solid education in computer science theory. You have very solid education in basic methods. And then just on top of that, then somewhere in specialization, you look at these new topics, be it AI or whatever, these things change. But I think this is a very solid basis, especially in a field that is moving so fast, right? I mean, imagine like 15 years ago, now, everything is not even machine learning, everything is Gen AI, right? So people talk, nothing machine learning is now Gen AI, right? And it used to be expert system, used to be different things. And I think people who get this solid layer of education, these people can go adapt and work. So that is, I think, we should not throw away what we have, because it's actually pretty good in many areas. Yes, the question is, how do you integrate new AI topics? And for me, that's more like a master PhD level, and it's important. And it brings me to a second point where I sort of agree and disagree with Ioannis, which is the sort of a splitting of computer science, AI, and other stuff. So I do agree that computer science has reached a level where probably it needs to be split at. And I really like this analogy to physics. I also did master's both in physics and in computer science. And one thing I'll never forget, when I was just starting my studies, I was interested in further topics. I love physics and computer science. So I would go into the advanced advanced degree courses in computer science, like neural networks then, and I could sit there and understand something. And I went to one advanced course. It was like quantum physics 3 or 4 as a young thing. And I didn't understand a word what the guy was talking about, right? And of course, that is what you see with this thing, that many subjects go in depth, computer science has breadth, but we have reached a stage where computer science needs to get more, and you have more depth, right? So you need the split. I'm just not really sure that splitting in AI as a discipline is the right thing to do. I think there are more, I mean, obviously computer engineering is one thing. Obviously things like software engineering can be a different area, right? But then you maybe it's more about algorithms than it is about AI, right? Because that's the other thing I always say. What I think of AI is the name, artificial intelligence. You know, it comes from this fascinating thing I love. How do you reconstruct what people do in machines? But today, AI is many different things, right? You have people who take AI from all the neuroscience area. How do you actually understand the brain, which is a fascinating intellectual endeavor. You have people who look for it more from my line of work. How do you build systems that can simply deal with the complexity of the real world, right? And you have people who look more in the philosophical area. So I'm not sure that the split like AI's own discipline is the right one, especially in education. But I do believe that computer science would need eventually, just like today, nobody would come with thinking electrical engineers should study theoretical physics, right? Although down the line, electrical engineering is just physics, it is its own discipline, right? The same is true for construction engineering and for stuff. So we do need eventually to have this in computer science. And the final comment on education is a PhD education. So one big difference between many European PhD programs, for example, the US one, is that actually in the US, PhD really has very strong emphasis on study, right? There are teach courses. In Europe, PhD students, especially in Germany, are just researchers. And I love the European model. I think that somebody who's reached the stage of being at a PhD, he finished a bachelor, he finished a master's, you don't send him to lectures and then let him write exams. They already demonstrated they can do that. They should have gotten the skills to acquire knowledge. So a PhD, right? Getting a PhD, at least in Germany, is defined as the proof of your ability to conduct scientific research, right? Just sending people to lecture is not the way to teach them. Well, there's something you should do them, right? Scientific methodology, right? Scientific communication. Some PhDs, especially in computer science, some of them can only speak in C and Java, but no other language, right? So I think these are things that you would have. But I think the most important thing is, how to teach them research. And this thing, again, I would like to be positive. I think that actually that the European research funding, for me, plays an extremely important role. Because you look, these young people, they start a PhD, and then you let them take part in projects like this, right? They work with people from different countries, they work with people from different disciplines, they work in industry. And I also think much more than in the US or somewhere else, we actually have these PhD students that take responsibility in projects, right? Actually do things. And they grow with it, and they become people who then go to industry, to go somewhere, actually do something. So I think this notion of education, right, of PhD students taking part in projects, doing research, students exchanges across Europe, and that's, I think, where European funding plays an extremely important role. And it should continue, and that's, if I look at some of the best people you can take in as postdocs or as professors, they grew up in those European collaborative projects. So that's mine.
And so next we've got Peter online. So Peter, do you want to share your slides? And my
yeah,
colleague here will
sure.
help you a little bit.
Sorry for the glitch earlier. I'm not a regular WebEx user, so let's see. Okay.
We can see your slides, yeah?
Okay, probably not in presentation mode.
Not yet, no.
What about now?
Perfect, Peter, yeah, looks good. Off you go.
Okay.
Thank you.
Perfect. Thanks very much for having me here, and sorry that I couldn't be there. It sounds like a great event. Right. I want to add a perspective from somebody who has been leading a Center for Doctoral Training for the past 5 years, and we've just extended and renewed our center. And I want to talk a little bit about that and then raise some questions at the end. So what are centers for doctoral training? So this is a bit of a UK-based perspective. So it's one of the main mechanisms in which the research councils in the UK fund PhDs. And the essential thing is that these are cohort-based. They have a fixed starting date. So every year we have about 10 students. They are fully funded studentships. And it's typically a 4-year PhD, and it starts with some kind of foundation year. And I will talk a little bit more about that. There is some space for international students, but it's mostly for home students. And the reason for that is that these CDTs are designed to address a specific PhD level skills gap in the UK. So that's how we got the funding. We needed to argue that we need people with PhDs in a particular subject. And AI is taken broadly here, so this could be across all research councils in the UK. So it could be applications of AI, but we are really about at the methodological side. So in the next slides, I'm just going to give you 2 slides about what we've been doing in the past 5 years. And then I will talk about what our new center is about and how it is different. Okay, next slide. So back in 2019, we started a CDT in interactive AI, and which kind of now with chatbots and ChatGPT and so on seems kind of like an obvious thing, but you have to remember that we bid for this in 2018, so we were slightly ahead of the curve. And one of the essential points of interactive AI was that we were working together with people from human-computer interaction, because the human in the loop aspect was important there. Let me just go to the next slide to show you what the structure is. So we essentially have a year 1, which was a pretty full year, which essentially is kind of like a 1-year master's course. So master's courses in the UK are a bit different from on the continent, and they tend to be, we think of them as 1.5 year, because students also work over the summer, which basically gives them the extra credits. ECTS credits is 90 credits for an MSc course. UK credits are twice ECTS credits, just to complicate matter. So the details are not that important, but we have, we teach them on data-driven AI in teaching in the autumn, teaching block 1, in the spring, teaching block 2. We teach them about knowledge-driven AI. We teach them about human-AI interaction, and then we have some cross-cutting themes and so on. Then over the summer, which we call teaching block 3, they do a kind of pilot project, which then leads into their PhD project. So this is what we've been doing for the past 5 years, and we are now the first students are graduating from this course. There have been some delays because of COVID and other reasons. So now let me talk about the Center for Doctoral Training that we recently got funding for, which we call practice-oriented AI. And I think it links to some of the things that Paul and Ioannis and Mohamed also were saying. So in a nutshell, this practice-oriented AI, you could also call it translational AI, is about software engineering for AI. So if you think about what is the difference between programming and software engineering, in computer programming, you develop domain-specific languages or high-level programming languages, and you think about how do I implement a particular algorithm. In software engineering, you actually start from the problem. you analyze requirements, you do requirements elicitation with domain experts, you come up with specification, you come up with a design, you start implementing a prototype, you go through some kind of feedback loop a couple of times to make sure that your implementation does, help solve the problem. And we need something like that for AI. And our starting point here is that AI is now mature enough that instead of sort of waving the AI hammer around and looking for nails, it's really, we have a big toolbox and we need to first analyze the problem at hand and then see what tool is most suitable for solving that problem. So that's really, we want to train graduates who can do that, potentially for a domain that is new to them. So we are less about training AI experts that know a lot about one specific application domain, but we want to train AI experts that have the flexibility and the knowledge and the methodological knowledge to do this for new domains. Okay. My slide doesn't want to advance. There we go. Okay, so again, this is in a nutshell what our program looks like. But the key point here is that we have what we call practice projects, which are very hands-on. So we work with our CDT partners who will give us a problem. And the key thing here is that the problem is not Kaggle shaped. It doesn't come with the data in CSV format and a neat objective to optimize. This is very artificial. Yeah, that the Kaggle model of challenges in AI is extremely artificial. What we want our collaborators to provide is a problem that is not necessarily AI shaped. It's just a problem that they care about. And then we will work with our students. The students will work in groups to see where AI can help, maybe redefine the problem or define a sub-problem and propose a solution for that. So that's going to be very hands-on. And we also the aim is to have students across cohorts, so across years, to collaborate on these practice projects so that different students can bring in different kind of skills and experience. So this is my final slide. So just some observations and questions. So the Interactive AI CDT was designed as a 1+3 course where kind of foundation year was kind of roughly a UK MSc, and then they carry on with 3 years PhD. One of the things that I discovered very quickly and that I hadn't anticipated but perhaps should have is that students then start with this idea that in the first year they are an MSc student, and then somehow over summer they transmogrify magically into a beautiful butterfly who is able to do research. So we wanted to get rid of that kind of separation. Also, we realized that if we design the first year full, if we give them a lot of teaching, then this takes time away from PhD research. So in the new CDT that is starting in September, we reduced the foundation year to 2/3 so that they have more time. They can start doing research from day one. We assume students have acquired essential skills in a previous degree, so we don't really teach them AI anymore because we assume that they know AI, and they will be assigned a mentor. So wherever there is, a deficit in knowledge, the mentor will suggest some self-study, and the student will do this through self-study. And then the kind of training that we provide is much more hands-on and group-based, which is the kind of thing that you can't really provide or learn in an online setting. So just to conclude with a couple of questions here, sort of, this idea of training and research, what is the right mix here? Because traditionally a PhD was only research, and then sort of you know, maybe also in the American model, there is a lot more training there, but what is the right mix here, given that you only have 4 years? And another question really is, what skills do we actually expect students to have going into an AI PhD? It's, you know, we interview students, we shortlist students, and then interview them, applicants, for these funded PhDs. But, you know, you get people with very different backgrounds, and it's not so straightforward how to decide whether somebody has the right background for something like this. And finally, and this may be a UK specific question, but I know that, for example, Barry is leading something very similar, and in Sweden we have the Wallenberg AI program. So in Bristol, we now have a mix of CDT students and non-CDT students. So we have people who do just 4 years research and don't get a lot of training, and we have people from the Center for Doctoral Training. How do you mix that? Sort of how do you make sure that after 1 year, students kind of, you know, are evaluated in a reasonable and in an equitable way? So let me stop there, and I look forward to the discussion.
Thanks, Peter. That's great.
And the slideshow. What do I do now?
Great, thank
Okay,
you.
there.
So I'm going to minimize this window. Hopefully that just works. And there we go. Thank you. You might put up the slide that we had, the holding slide.
Mm-hmm.
Great.
And
So I guess one of the big questions for me is obviously we've just sort of launched in some sense the AIDA curriculum, but I think we've heard very different views on the importance of a curriculum per se. Paul thinks that students should just get started and just work on the research, and I think Peter has this foundation year, and Ioannis has this view that well, Ioannis has the view that I suppose that it's very much part of the curriculum is important, maybe, that, if I may say that. So could I just ask the panelists what they think is the role of a curriculum at the PhD level, and is it important to have? Is it important to teach courses like that, or is it important to use the curriculum maybe as a benchmark to understand what the students need to have coming into the program? So maybe I'm going to go to Ioannis first, maybe, and then back, you know, and then maybe people can come in as they wish.
You know, Barry, we have a complicated situation in Europe, not only Europe, in all, let's say, the Northern Hemisphere.
Sure.
We need PhDs for postdoctoral research, and our graduates are not really enough. So we have to import people from Africa, from many different areas, and this adds to the diversity of the studies, because at the very end, we should have qualified scientists that have the basic knowledge plus research capabilities. And the question is how to do this.
Yeah.
This means that, to me, the AI PhD curriculum is just an indicator of the level of general knowledge that a PhD holder has. And I don't know how we can certify this, but maybe, you know, there could be exams at the end of the first year, something like qualifying exams that the American universities have, and then no matter if a PhD student comes from University of Thessaloniki doing her or his bachelor degree there, or from somewhere from Asia or from Africa, before or at the start of the research, they have to prove that they have the basic knowledge, so they have the foundations. And if they have good foundations, of course, then they can excel in their research.
Okay, very good. Peter, do you want to respond to that? Because obviously you have this foundation year, so obviously you've changed that model between your two CDT proposals for a very good reason. So do you want to talk about the importance of a curriculum, and whether it's important to teach courses in these areas, or whether it's, you know, assumed? What's the role of foundation teaching in PhD level and so on? Thank you.
Yes, so as you've seen, my thinking or our thinking has evolved there because it's kind of, and of course, the background to this is I've been in the UK a long time, as you know, and maybe 25, 30 years ago, a UK PhD was supposed to be 3 years. And then they recognized that most people don't finish in 3 years, and then sort of it got extended. And in a way, if you now have this foundation year, you kind of go back to a situation of 3 years PhD proper. It's also a question about, so, you know, some people see this foundation year as a kind of remedial teaching. Oh, you're not yet ready to do a PhD, but we're going to teach you some stuff. Right. And I've been fighting against that. So my view of this is we do this foundation year so that you can get further in your proper research, because we teach you skills that, you know, wouldn't otherwise be so easy to be acquired, which I think has that hands-on element and cohort-based element very much. So, but I don't want to, you know, it's a very specific model. I think the essence of what we are doing is cohort-based. So what do we do if we have a group of 10 students who all start at the same time? And you see very interesting group processes going on there. And they really build connections that we want to, you know, that we want to keep in later studies. So I've come to believe that rather than the specific curriculum, it's really about building on this cohort idea, which of course, if you have an international PhD program such as AIDA, is an entirely different thing, because you don't really have the cohort and you can't build the cohort in an online setting. So the curriculum, which I think it was a fantastic exercise to do as the networks, and I'm really proud of what we've come up with as an AIDA curriculum. But of course, if you take it at face value, that's a 4-year program in its own right. If you want to really do the whole AIDA curriculum and then specialized in you know, the human AI aspect or the trustworthy AI aspect, that's a 4-year MSc course. So I'm still not sure how that relates to proper PhD training. So, but don't get me wrong, I think it was a fantastic exercise, and it really helps us to sort of develop a language about thinking about these things. So that would be my perspective. Thanks, you.
Peter. If I'm going to go to Paul, because Paul, I think you have a bit of a different view, haven't you?
Yeah, so I was, arguing against this taking course exams, and I stick with it that, PhD should not involve people being forced to take at least technical courses and do exams. Which doesn't mean two things. First of all, I very much agree with the need for a curriculum, as what Ioannis said, something that shows you what are the things that you should know if you go into the PhD, and what can you expect from people who did a PhD to know. I also think that it's important actually to provide educational materials on those subjects. Not just to say you have to take those courses, but if somebody with a PhD, he or she should be able to go there, actually get the material and self-learn, right? I think, so for me, I would say that somebody who actually needs to take courses like at a university to be able to complete a PhD didn't earn a PhD, because they have to learn themselves. That's part of being a scientist. But I do believe that there should be courses that PhD students should be forced to take, including exams. And those are things that are sort of on the periphery, things they wouldn't learn otherwise. Scientific methodology, right? It's something where I think if you do a PhD, you should be actually obliged to show that you know, right? Some things that they relate, for example, to ethics, right? Maybe, social aspects. I think if you look at AI, getting them maybe to do 1 or 2 HCI courses is something, but it's something they wouldn't do, right? It's this thing, if they have to solve a problem, they lack a technical skill, either they acquire it themselves or they did not earn a PhD. That is fair. But actually teaching them that you need to take into account, for example, some HCI is something they wouldn't otherwise do, and will teach them better. So I think that is really the way I see for the curriculum as being important, but not in a sense let them, because as you say, then that would be like a 4-year master course. They wanted to do all the courses.
Yeah, great. So if I may ask a slightly different question, Mohamed, and of course, Mohamed, feel free to answer the comment on this one. But what do you think is the right blend between the sort of theory and the practice? I mean, the course material, for example, the formal course taking versus at the other extreme, the actual doing of projects with, for example, an industry partner. So where do you feel is right blend between the theory and the practice? And obviously you've put together this great handbook, and so you might have some really interesting insights on that one.
Thanks for the question. I think that's something that is making, let's say, a very big difference today in AI is that we have open source codes, and maybe 10 years ago, or even 15 or 10, you may have a project that will take you maybe months before you do something, and today maybe in one day, in one practical, and in 4 hours, you could do very let's say impressive things, and of course you cannot. So that's first one point that is really important, and also industrial partners and industry is also building on that, is trying to get very fast and to be deployable. So we need to train people also to do that. But the risk is also to have only toolbox effect, is that you can only use things and you don't really understand what you have here, and so that's the main risk, is how we can train people so that they can, of course, for example, not being expert of something, but they can use it, as Paul was saying, HCI and others, because you need it. But still, you need to develop people that a methodology that they know how to integrate things, because a lot of things that we are doing today, at least for on research, but also in industry, in practicals, in project, is integration. So I like the way Peter was presenting the software engineering. Sure. It's a very nice way of addressing and this is really realistic. So I would say we need to do that, because that's life. I mean, it's what is making changes, and we see that in other countries. There were discussion about Africa and others. They really are able to do or to reach state of the art because we have open codes and open sources and resources, which is very nice, and this is what is happening. But we still need people to understand that and to understand the core, because things will be changing very fast.
Okay, thanks, Mohamed. I'm going to look at the room. Does anybody have any questions that don't ask? It would be great if you did. Make it interactive. But while you're thinking of your question, I'm just going to continue with that question of what's the right blend between theory and practice with the panel. Peter, Paul, Ioannis, do you want to comment on that at all? Yeah, go ahead. Yeah, please. And maybe say who you are as well, so that the people online will know who you are. So there's a microphone coming to you. Just 1 second, because the people online won't hear you. Yeah, thank you.
My question is a bit not so much on the input or what the PhD students learn, but my concerns are that there are not many startups or real projects are coming out of this AI exercises. And what probably could be done in this curriculum and in the whole process of PhD to encourage that, because we are talking about impact, but I'm not so sure that we have huge impact with these programs.
Okay, so I'm going to direct that to Peter, actually, because Peter probably has a lot to say about that, because given the things you've said in your presentation. So how do you make sure that things are relevant, real, have impact, and so on? Peter, over to you.
Yes, yeah, that's a very good point. So as I said, the justification for the research councils to fund this is because they want to address a skills gap. So they, the UK needs people trained at PhD level with certain skills, and that's how, that's the case that we had to make. So that implies that most people coming out of these programs are not going into academia, although you may say that there's a skills gap in academia, but it's much broader than that. And we do things with things like entrepreneurial training, for example, but again, we were a bit naively, when we started 5 years ago, we gave them a whole module on entrepreneurial, the ecosystem and how to be an entrepreneur. We got pushback from the students who said, "Oh, I don't want to be an entrepreneur." And so, but then we say, well, yeah, but maybe at some point you have to talk to an entrepreneur, or you have to engage with that kind of part of the world. But so in the end, we made it optional. So a lot of the training that we provide is optional, because there is no point at this level in forcing people to take training with which they don't have any affinity, right? So, and it's also wasting resources. So I see these kind of centers much more as enablers for people who are interested in particular things.
Sure.
But yeah, I mean, how do you measure impact? We've only started delivering our graduates, so it's a bit early to say where they are going and what they are doing. But certainly, I would like to think that maybe in 5 years later, I would like to think that some of them will have started their own startup or joined a scale up or whatever. Some others have maybe gone into AI managerial, leading AI departments or setting the strategy within companies. So I do agree that that's where we should look for our impact as well. The old model of our PhD prepares you for an academic career, that's not what this is about.
Yeah, very good. Thanks, Peter. Paul, go ahead. Yeah.
Let me comment on that. There are two things. First of all, I've had PhD students actually went on to do a startup, and it was very satisfying. And I think it's something that facilitating or helping them do that is important. I would extremely strongly push back about this notion, how do you make sure that our PhD research that is done leads to more startups? PhD is actually scientific research, right? It's PhD at a university. And saying we change the way we direct our PhD what to do to make sure they do startups is not the thing what should be done. I think that's with so it's okay. And we have PhDs who work together with industry, then it's more relevant. Yeah. And I feel very strongly that you should. I agree with Peter that forcing everyone to take entrepreneurial courses doesn't make sense, because you just piss them off, so to say. But giving the opportunity, right? Really connecting them to entrepreneurs, those who want. Yeah. Give them the opportunity to learn. That is important. I agree. Sorry.
So there's a question here, a response to a question here. So yeah, if we have
I think he wanted to respond directly to me.
He wants to respond to you directly. Absolutely. And there's a question further on that bench, and then we're going to have to wrap up. I'm afraid.
With impact, I not only mean startup impact, impact in general. So that could also be academic impact or social impact. It's just not measured very well.
Yeah. Well, certainly there needs to be a rubric for impact evaluation. There's a question in the middle of that row right there. Blue shirt, yeah, great. And then we'll probably ask each of our panelists just to maybe make one last remark before we finish up.
Yeah, sorry. I know that I'm the last obstacle before the coffee break, between you and the coffee break. So, and I'm going maybe to send a stone in the little pond. Before everything, I just want to say that I'm a computer scientist teaching AI for decades, and so I'm part of the crew. But it's a question that is for both tracks that we had this morning. Don't you think that both in the previous discussion and this one, we miss some pessimistic, tech pessimistic contributors to the training programs? Because we are more or less only computer scientists, teachers, professors talking here. And all these curricula, either PhD or the previous one talking about AIDA, we are really keen on looking for people like us. Maybe we allow some debate between symbolic and non-symbolic AI. That's sure. the farthest that we go. Yep. But I think in regarding the importance of what we're discussing here, that's what I'm trying to do myself in the university, in our university, to promote, to get some people coming to say, okay, if you talk about ethics in AI, that should not be some fairness, how to put fairness in algorithms solution. It could be someone from a completely different field.
Sure.
coming to say AI is bad, maybe, or if you talk about AI for energy saving, we are proposing AI solutions to solve. Maybe that's don't run AI at all. And there was also the comment in the previous panel saying, okay, do you use AI for correcting the algorithm, correcting the exams? And there was a small sentence saying, okay, AI is going to make a proper correction and going to make a proper comments to. Come on, we know those algorithms. We are playing with them all day, and we are even making our owns that don't working that well. So I think there is a missing. There is a whole.
So we certainly need to be more pessimistic a little bit, and certainly take that view on board. What I'm going to ask our panelists, maybe just to wrap up, is this, you might wish to respond to that about the need for being more pessimistic about and more, I suppose, critical about the role of AI, maybe in some sense. But also you might want to make a final remark. So I'm going to go to Ioannis first because he hasn't spoken in quite a while. So you might, so your closing remark, Ioannis.
My view is that we should stress the foundational nature of the university studies. So our graduates, no matter if they are master graduates or PhD graduates, they should have a solid foundational and mathematical, in our case, background that is going to help them survive through various revolutions that they're going to see in their life. And I would rather talk about forming or educating citizens and scientists rather than upskilling and reskilling.
Very good, thank you. Paul, do you want to say something?
Just want to respond to that. I think for me as a scientist, the point is no. Pessimistic, no. Actually, optimistic, also no. You want people to be trained to do rational, objective, cost-benefit analysis of things, right? So no, pessimistic is bad, as is optimistic, right? We want to train, and I think that comes from me. PhDs should be trained as scientists, and that is the point. You train them as scientists that you expect of them to actually be able to not run in one direction, but see both sides of the coin. And one remark is, as a computer scientist, we tend to say, if it ain't broken, change it. But actually, with respect to European PhD education, maybe you should say, if it ain't broken, don't change it, right? Or be careful, because I think it's not bad. We really do educate good scientists.
Absolutely. Great. And Mohamed, do you want to comment on that? And then I'll go to Peter.
Yes.
Or maybe your final remark.
Yes, fine. I think the curriculum also, and this is also linked to what has been said before about pessimistic or the optimistic, that I think the main advantage, and we already said that, of the curriculum is also to put in disciplines that could help to critique. So if you, during my presentation, I mentioned, for example, people from sociology, people from philosophy and others. So they are taking part of the curriculum, and by, let's say, having students and trained, and even in a court or not court, but mixing events and training events where you have people that are more following the core AI background and others, this will really help on that. And I think I agree, it's not a question of optimistic, pessimistic, but having different point of view, and the curriculum highlights that. And we already have implementations showing that we are able to merge these disciplines.
Good, thanks, Mohamed. Peter, final remark to you.
Yes, thanks. So, I mean, reflecting a little bit on all of this, I think a lot of these discussions are essentially driven by the question, what is AI? So, Ioannis talked about that, but also actually developing the curriculum is simply just, in a curriculum form, address what is AI, what's in it, what's important, can we prioritize things a little bit. So I think we should acknowledge that that's the level that we are at. We are still finding our feet and saying it's not a well-established discipline. There is not broad agreement on that. So that's what we're doing here, I think. The other thing that we have to address in a European context is there are such differences between countries. So, on the one hand, we talk about PhDs, but in different countries, the procedures are very different and the requirements are very different and the tools that we use are very different. So that's simply what we have to deal with in a European context. And also we need to be a little bit realistic in what we can achieve at the European level, given that there are such differences between countries.
Good. Thanks, Peter. I think just my final remark is, when you look at the curriculum, which I encourage you to do so, please do sign up to give a course or to send us your teaching materials. I guess the other question is it really a PhD curriculum at all? And is it actually just a curriculum for AI? And so could this curriculum be brought down into the undergraduate level? And would something change if we brought it down to the undergraduate level? That would be an interesting question. So I will leave you with that question, audience, and maybe you can get back to Ioannis or myself or anybody else on the panel. And I want to thank Paul, Ioannis for being here in person, and Mohamed and Peter for being online. So thanks, everybody. It was a really fantastic panel. Delighted to have you all. So let's show our appreciation to the panel. Thank you very much.
Thank you. Enjoy the rest of your day.
Good. Thanks, Peter. Thanks, Mohamed.